Now we can see the KNN classification here. So we are going to perform classification using KNN, and we are going to use iris dataset for this, which is a familiar dataset, and you are already familiar with the iris, right? So we have something called this Setosa, and we have versicolor, and we have Virginica, right? So we have these three different classes that we are taking, and we have to classify the data into. So I have just visualized the data so that it is clear for you and you can see. So we have this sepal width and sepal length and petal width and petal length, right, which are your features, and final classification of the classes are these three different classes that you have to classify your data set to. So this is the data, this is regarding the data, and we are going to implement our KNN algorithm to perform the classification. So we have splitted the data into X and Y respectively. X will be your features and Y will be your whatever the target species is. And now we are going to use train test split method, which is available in sklearn. What it does is, if you give the test size as whatever that 0.2 is there, right? So in the sense, like, your test data and training data is split in such a way that your test data will be 20% and your training data will be remaining 80%. So this is how the splitting is done. And now we are transforming our extreme, whatever the extreme values, using a standard scaler, and even the expressed also we are doing the transformation using the standard scaler. And then now we are fitting our KNN classification algorithm. So we have defined it, and you can see that you can mention the number of neighbors here, whatever the key value is there. So we have taken it as 10, and you can see the hyperparameters here. So there are no much. This is the main one, nearest neighbors, and even we can change the distance metric also. So by default it is min cos p, so you can change it to different types of metrics as well. And when you are doing the prediction part, so you can do the Y prediction. So this is the Y prediction that we have, prediction output, whatever the KNN prediction, right? Now we are going to do the comparison between the actual one, whatever the ground truth, Y test ground truth, and the Y prediction. So whatever the predicted values it has predicted, the model has predicted. So you can see it. So it is almost similar, right? So this is just for our illustration, but we'll try to plot the confusion matrix. So we can import the confusion matrix, and we can feed this Y test and Y prediction to the confusion matrix, and you have obtained the confusion matrix, right? So you can see that you have these three different classes: class 0, 1, class 1, class 2. And class 0, it has predicted all 11 samples properly, and class 2, it did one misclassification, and class 3, it has done one more misclassification. So you can clearly look into it in confusion matrix, right? And also, if you want to calculate the accuracy part, you can see the correct predictions as 28. 28 correct predictions it has done, and two false prediction it has done, whatever we have saw in the confusion matrix, right? So total samples are basically 30. So you can also, like, if you do a sum of this complete matrix, if you find sum, you will be getting your total number of samples. So you have 11 plus 8 plus 9 plus 1 plus 1, which will become 30 for you. So from class confusion matrix also, you can interpret the accuracy of the model or the performance of the model. And also we can clearly know the misclassification. Suppose this particular class is misclassified, to which class it has misclassified. So obviously there's a misclassification, but if you see this particular class, there is no misclassification that has happened here. So you can see it clearly. And then here, if you see, you can see the accuracy, right? Finally that is obtained. So accuracy is nothing but, now if you check, it will be 28 by 30, right? So if you calculate that, it will be 93.3%. So this is the accuracy of our KNN classification. And what you can do is, you can change the K value, whatever the number of neighbors, right? Whatever that hyperparameter is there, you can change it accordingly, and you can try to check, like, are you able to increase the accuracy or not. So by changing the K value, and also you can plot the K value, whatever the one I have showed you in the presentation, and you can make something similar plot, and you can check, like, what is the optimal value of K. So I have taken K as 10, but you can, I cannot, like, I'm not guaranteeing that it is the optimal one, but you can, as exercise, you can take it yourself and change the value of K respectively, and try to find the optimal value of K.